So another example, there are three numbers, 252, 396 and 468, and we have to find the greatest common factor of these three numbers. So these are large numbers. You just put all these three numbers together as we did in LCM. In LCM, we were looking for any number which is divisible by any of these, but now it's a little bit different. So you have to make a comparison between this and the LCM method, because otherwise you don't want yourself to confuse. So here what we do is we try to find out a number which is divisible by all of these numbers. So this is the difference. In LCM, we were using any of a number which is divisible by any of these, but now we are looking at a number which is divisible by all of them. So because they all have even number at the end, 2, 6 and 8, so it means 2 is divisible by all of them. So we divide by 2. If there is no such number, we stop right there. So 2, so 1, 2 and 6, 2 ones 2, 1 and 9, 19, 2, 9, 18, 1 and 6, 2, 8, 18, 2, 3 and 4. Now again we have even number at the end. The number is divisible by 2. So we divide it again by 2. 6 and 3, 9 and 9, 1, 1, 7. Now these numbers are not divisible by 2. Now using the divisibility rule, we check for 3. So 6 plus 3 is 9. So number is divisible by 3 because 9 is divisible by 3. So 9 plus 9, 18. 18 is divisible by 3. So this is also divisible by 3. So 7 plus 1, 8 plus 1, 9. 9 is divisible by 3. So it means 117 will also be divisible by 3. So we divide by 3. 2, 1, 3, 3, 3 and 9, 27. Again we check and the numbers are divisible by 3. So 7, 11 and 13. Now these are prime numbers. So we have to stop here. We have to stop here because there is no such number which is divisible by all of these. No such number which is divisible by all of these. So we stop here, and if we multiply these four numbers, which we will get the GCF. So GCF equals 2 multiplied by 2 multiplied by 3 multiplied by 3, 2 to 4, 3, 12 into 3, 36. So this will be the answer. So the same method, but in a little bit different formation. You can use it for 3 numbers or more numbers. Now I will explain another situation where this method is not very useful, and you can realize it in a very first step of using this method, and then you can use another method, which is the third method or second method, whatever you call it. Now let us take another example. We have to find the GCF of these numbers. 85, 102, 136 and 153. So if we use the previous method, you can immediately see that this number is not divisible by 2. So we don't have to check all these numbers for 2 because this is not divisible by 2. So we don't have to check these for 2. Now check for 3. 8 plus 5 is 13. 13 is not divisible by 3. So number is not divisible by 3. So we don't have to check other for 3. Now go for 5. 5 is at the end, so the number is divisible by 5. But when we go on the second number, this is not divisible by 5. So we don't have to check any other number for 5. Now what about 7? If we check for 7, the first number, it's not divisible by 7. So we don't have to check any other for 7. So now it goes on and on. And the next prime number is 11. If you check for 11, this number is even not divisible by 11. Not divisible by 11. So we don't have to check. So it means the previous method is not very useful in this situation. So what to do now? So now there is another method which we can use in this type of situation, which rarely occurs in algebra. But this is just a situation which can occur in arithmetic question, or when you are doing some competitive exams, then you might find this situation because they select questions which are a little tricky. So in those situations, you will find that that method may not be very useful. So in this type of large numbers and kind of hostile numbers, which are not divisible by small prime numbers, if they are not divisible by small prime numbers, then we use another approach, which I am explaining now. So what we do in this case is, we divide the largest number, 153 in this case, with the second largest number, which is 136. It goes one time, 136, and we get 17. 17 is the remainder. Once we get the remainder, then we put 136 inside the second largest number and divide it by the remainder of the first step. And now it goes 8 times, 136, and nothing is the remainder. So it means that this 17 is the GCF, or the greatest common factor between these two numbers, between 153 and 136. It is the GCF is 17 between these two numbers, because 17 is divisible by both of these numbers. So now we check this with the third number, which is 102. If 17 is divisible by 102, then this will be the greatest common factor between these three. And then we will check with 85. And if 17 is divisible by 85, then it will be the greatest common factor among all of these four numbers. So what we do next is, we divide 102 with 17, and it goes 6 times. Now we divide, it means the 17 is the greatest common factor between these two and between these two. Now we divide by 85 and check whether it is also a factor of 85. So now it goes 5 times, 5, 3, and it goes 85 exact. So it means 17 is the number which is a factor of all of these, and which is the greatest common factor. So greatest common factor equals 17. So this will be the answer. So this is a method where we do a step-by-step process. We just take the first two numbers. So if a greatest common factor exists, then we will find it. And if it doesn't exist, then these numbers are relatively prime. They are called relatively prime numbers. Means that there is no common factor except one. For example, let's take 28 and 45. So we take, because it's simple to take the first method. So 2, 14, then 2, 7, and then 7 is 1. Now take 45. So 5 plus 4, 9, so 3, 3, 5, 1. So if we write the prime factors of 28, is 2 into 2 into 7 into 1. And 45, 3 into 3 into 5 into 1. So you can see that there is the only common factor which is common between these two is 1. And 1 is really common to any two numbers. So these type of numbers are called relatively prime. There is a term used for this number, these type of numbers. So they are called relatively prime numbers. So it means that there is no common factor except 1. There is no other common factor between these two numbers. So using this method, you can find the greatest common factors between large numbers if one exists,